This is lecture 2 with the title ContextFree Grammars. Oh, sorry, ContextFree Languages. It's part of a computer theory course called Introduction to Theory of Computation. It's a senior level M1, meaning first year master's level course, so a bit of both. The author of the text is Sipser, Michael Sipser. Here's the text. Now this is the Chinese version. The English version, or American version, would be this book here. Okay, I have the Chinese version. It's the second edition. It's pretty well become the Bible, the main text, the most popular text on theory of computation, which is why I've used it, despite the fact that it's over 400 pages, so it's going to take me like 3 months to get through. The first chapter, it's the beginning of the second chapter. The first chapter took me, I don't know, something like 115, more or less, video clips uploaded to YouTube. So a long course, that's the downside, but it's a very thorough course, and I have some quibbles with Sipser. Sometimes he just throw things at you with, and maybe he feels that they're so obvious he doesn't really need to explain them. But sometimes I have to think hard. Right. Now a more general statement. This course is just one of many that I intend to do in the future years, even decades, if I can keep it up. And my health, because I'm mid-60s now, retired professor, so my new career, arcing, that's after retirement careering, so I label myself an arcer, and my new career is making YouTube videos, largely in graduate level math and physics, so that's where the MPC comes from. So math, as in pure math, P for physics, mathematical physics, and C, computing theory. About 10%, if that, of the total number of courses will be on computer theory, most of them on pure math and math physics. So it's largely an MP series of courses. And I call this series deGarisMPC. deGaris is just my family name. So if you want details on all these courses, and this particular course, and the textbook and so forth, and the chapter titles, and so go to this website. So Prof Hugo deGaris, all one word. Prof short for professor, because in a previous life I was a waged, meaning salaried, professor. Now I'm a free prof. I give the graduate level lectures uploaded to YouTube for free. So you parents particularly don't have to pay many tens of thousands of dollars a year on education for the kids. So hopefully this will revolutionize education. So profhugodegaris.wordpress.com. Okay, and there are various tabs on that main web page as it comes up. So click on the tab that says deGarisMPC, and then you'll get into all these courses. Well, I mean, to be watching this, you've presumably done that already. So, right. So chapter 2, called ContextFree Languages. So they are languages that are free of context. We don't quite know what that means yet. You don't know what context means. Well, I'll just give you an overview. Say you look at a symbol, and what you do with that symbol depends on its neighbouring symbols. So what you do then depends on the context, in other words the neighbourhood of that particular symbol you're looking at. So that would be context dependent. But this whole chapter is about languages whose strings, remember a language is just a set of strings. So it's languages where when you look at a particular symbol in the string, you don't care about its neighbours. You don't care what symbol is on the left of it or the right of it. Okay, so you don't care about the context. So, so context-free. You're not interested in the context. You don't care about the left neighbour or the right neighbour or whatever. Okay. Now, so a bit of overview, setting the. Well, a bit of an overview of Chapter 2. Now in Chapter 1, to make a bit of contrast, we introduced two ways to describe languages. One was finite automata, okay, and we went into that at length. And the other way to describe languages, regular expressions. Okay, and we had theorems showing these two ways of describing languages were equivalent. You go from one to the other, and did that at length. Like 50 pages or more. It's a long chapter. Okay. So these two ways of describing languages are equivalent. You can go from one to the other, and you can describe many kinds of languages using finite automata and regular expressions. But such languages are limited because you can easily find other languages. Here's an example here that cannot be described by a finite automaton. Okay, therefore, by definition, it's not a regular language. Remember, a regular language is a language that can be recognized by a finite automaton. And since regular expressions and finite automata are equivalent, you can a non. I didn't say that, but so. In Chapter 1 did not make that explicit. But so if there's no finite automaton that recognizes the language, then you cannot find a regular expression to describe that language, I guess. That would seem, I mean, that wasn't spelled out, but that seems reasonable. Anyway, all right. Okay, so there are other languages that are non-regular, like this one we did earlier. Okay, that cannot be described. Can't be described by a finite automaton or regular expression. Now, this chapter, one of the main ideas it introduces is something called context-free grammar. And so, give you. This is all very introductory, right? Just getting an overview of what the chapter's about before we even start on the first. Section, which would be 2.1. The 2 refers to Chapter 2, and 1 and point 1 refers to the first section. And now this chapter's not so long. I think it's only about 30 pages. So how many sections does it have? 3 sections. First section is called ContextFree Grammars. Second section is called Push-down automata. And the third section is non-context-free languages. Okay, so about 30 pages. All right. So one of the main topics of this chapter is context-free grammars. So what's a grammar? Well, again, just a broad overview, an introduction. Not too detailed, just give you a feel for what a grammar is. A grammar is a set of rewrite rules. And so what's a rewrite rule? Well, it's a rule that tells you how to rewrite, in other words modify, change, a string. So you may have a string of symbols. Now, I'm glossing over details, but just roughly. So to rewrite a string, you'll have your original string, and you modify it. You change it some way into some other string. Okay, and then you have your original string. Call that, say, S1, string 1, and you use some rewrite rule that tells you how to modify, change that string. So you change the string, and now you've got a new string called string 2, S2, let's say. Okay, and then you could use some other rewrite rule that's in the grammar. So the grammar is just a set, a list of these rewrite rules. So So you might use a different rewrite rule and change, modify, rewrite the string S2 into another one, S3, and so on. So you start with some start string, if you like, and by applying these rewrite rules, you eventually get some final string, let's say. So the set of those rewrite rules, that's called the grammar. So the grammar, in a sense, given the starting symbol, the grammar specifies what final strings you can get. So you're probably getting a feeling already that a grammar could describe a language, right? Because it specifies all the possible final strings you could get, starting from the start string. Okay, so a grammar is, in fact, it's a more powerful way to describe languages than what we've done in the previous chapter on regular languages. Okay, you can do more with it. It's definitely more powerful. And one of the reasons why that is these grammars, they have a kind of recursive nature. Remember from previous chapter, recursion, what is that? Well, you have some algorithm, some procedure, some